Okay, so in this segment we are going to be looking at singly linked list. To start, a singly linked list is a linear data structure similar to an array where each element consists of a data and a pointer to the next node. This is a formal definition of a singly linked list. Now there are a lot of technical terms in this definition: linear data structure, node, and so on, which you will formally be studying in your data structures course. But to put it simply, a singly linked list is similar to an array in the sense that it is a collection of elements of the same data type. The only difference being every element is made up of two parts instead of just the usual integer or character you have. So the two parts are data and address, the integer part and the pointer to the next element. So we'll try to understand this with the help of this diagram. So typically in an array you have, if it is an array of size 5, if it's an integer array of size 5, then you have 5 memory locations usually adjacent to each other, and each of those locations stores a number. That is how an array is located. But in a linked list, every element of the list exists at a different location in the memory. They do not have to be in adjacent or contiguous locations. So how do you move from one element of the list to another is, every element, apart from the data it contains, it also holds a pointer to the next element. So this is your first element. The data it stores is 10. The pointer to the next element 200, we will come to that, and this element lies at memory address 100. So basically this is an element of a singly linked list. It has two parts and we will come to the parts, but first of all its memory address is 100. So because this is the first element, this is called the head, and you have a pointer to the head, meaning you have a pointer which points to the memory address number 100. So when you go to this 100, you can first access the data located at this address, the data part, which is in this case the integer 10, and then you can find a pointer to the next element of the list, which is 200. So you go to memory location 200, again you can access the data, which happens to be 20 in this case, and then you find a pointer to the third element of the list, the location being 300. So we go to location 300, again we access the data, which is 30, then we find a pointer to the fourth location, and so on and so forth. So when you finally go to the last node, it will have a data part, and the last node, meaning it does not have a next location, so its address part will be null. That is the basic definition of a singly linked list. So to sort of recap, it is similar to an array. It is a collection of elements, all of the same data type, but they are not stored in continuous or adjacent memory locations. Each element is stored at a different location in memory, and they do not have indices, array of 0, array of 1, so on. There are no indices. So in every element, apart from the data it stores, you also have a pointer to the next element of the list. So when you are working with a list, you will only be given the pointer to the first element, which is called the head pointer. So you go to that address, you access the data, you also find a pointer to element number 2. Again you go to that address, you access the data, you find a pointer to element number 3, and so on so forth, until you find a pointer to the last element. So when you use that pointer and go to the last element, you access the data, and then you find that the address part will be a null value because there is no next element. That is a basic definition of a singly linked list.